Well, yeah, maybe it's good I didn't record the beginning because I'm so unorganized. Okay, of course, I just admitted to the whole world I'm unorganized. Okay, um, so okay here. So let me open up Eclipse and let's see here. I think this is what we did last week. Okay, so yeah, so last week, if you remember, what we did is let me just share the screen with you right now. So I'm going to share Eclipse, and I'm just going to remind you what an interface is. So the slides, the interface slides are up there. And this is not actually in that Zybook. We're going to start the Zybook today, or that's what I'll do a little bit at the end. But let me just share Eclipse with you, and so let me just. So this is something else, and okay, so this is the circle class, if you remember. So if you just forget about the class itself, public class circle, this is something you could have, for the most part, done in Math 130. If you forget about this implements comparable. And if you remember what we talked about last week is, okay, so an interface, all an interface does is it actually defines a method. So here, let me just put this in a comment here, just to remind ourselves. I'm going to put this in a comment. So let me get, I don't like all these stairs. So this would be an example of the comparable interface. It actually is when you install the Java development kit, it's automatically installed in your computer. So oops. Okay, so there we see the interface. So there's this interface called comparable, and all it does, it defines one public method. Well, the methods in an interface are public, but defines one method compared to, and that method returns an int. So notice in the interface is a review that that the interface only defines like a method header. It doesn't define the contents of the it doesn't define the contents of the method. That's our job. That's our creative part of the assignment. Okay, and so if we say a class, so then if you look at the header for the circle class, this is what's different between Math 130 and Math 140. You do see how we have implement circle, right? So we're implementing circle. So again, the word interface and implements are keywords, meaning they can't be used as variable names. So if we say a class implements comparable, that class better have a method called comparative that returns an integer. And also notice that we're using generics. The diamond operator, the less than and the greater sign, that's generic. We're just passing a class name. And so it's kind of strange. So all we're saying is, in this case, what's inside the diamond operator is identical to the class name. All we're saying is we're comparing circle objects to circle objects. Theoretically, you can compare a circle object to a person object. If we did that, then we'd put person in here. But I don't think I've ever seen it where it hasn't been the same. Okay, so we're going to compare circle objects to circle objects. Okay, so in our example, T is assigned circle. So that means that that compared to the parameter to the compared to method is going to be also circle. And we're going to return an integer. And if you remember the rules, if A dot compared to B is positive, then A is greater than B. Right? Okay, so OBJ dot compared to some returns a positive value, then because we cannot use the greater than or less than operator. with objects. We have to use this compare to method. And so if you look at this particular, this is what we did last week. All we're doing, so I'm saying that it is up to us to define what's greater than or less than. And usually if you line things up, we usually start from smallest to largest. And it's up to us to define what's largest. So if you notice, we're taking the difference of two radii. And that's positive if the current radius is greater than the radius of the input operator, of the input object. Okay, so we're just taking the difference of the radius of the current object and subtracting up the radius of the input object. And so if the input object has a smaller radius, then the current object is greater than the input object. And also we could actually change this around. I could say, well, the smaller radius is considered to be the bigger object, right? So if we go c dot radius minus this dot radius, then if the radius of the current object is smaller than the input argument, then the object is greater than the input argument. So I know it's a lot to think about. So it's not really, once you think about it, it's not too bad. But here, so this is what we did last week. And students, don't be shy about asking questions. And so then we had this array of circle objects. And so one thing we did is okay, so like 80 is greater than, so let's just run this again. So in this case, I have the compare to method is this dot radius minus c dot radius. So the bigger radius is the bigger circle object. And so here, circle 0 has radius 80, and circle 1 has radius 4. So what this is going to return is 80 minus 4. It's going to return a positive value. And here, circle 2 is, well, that's 1, right? No parameters. That gives you a radius of 1. So here we're going 1 minus 80, and that's 79. So it's returning a negative value. So circle 2 would be less than circle of 0. Okay, so that's one thing we did. Then we're just displaying the two-string method for all the objects. So we just display the radiuses or the radii in the order in which they're listed. And then on line 22, there's this built-in arrays.sort method, which uses our rule. It uses our compare to method to sort the circle objects in place. So it's going to actually change the order of what's in the circle object, that circle array, that circle ARR. And then we're going to print out the circle objects again. So hello. And so here, so here was the original, right? The original list, radius 80, 4, 1, 6, 33, 55. And then when we sort it, the last circle object listed is the one with radius 80, because we said the larger the radius, the larger the circle object. But again, we can make up our own rules, and now we'll sort it again. And now we're saying the smaller the circle object, the smaller the radius, the smaller the circle object. This returns a positive value. See, we're subtracting, it's c dot radius minus this dot radius. So this is positive when the radius of the current circle object, that's the one on the outside, that'd be the outside object, the one that's calling compared to. So when the radius of the current circle object is less than the radius of the input parameter, then it's positive, right? So this is positive when the radius of the current circle object is smaller than the radius of the input argument. And so now we'll just do this again. Hello. Yeah, so now you see, okay, so sorted list. Again, the last one, so that arrays.sort puts the largest circle object at the end. So the largest circle object in this case is radius 1, the one with the small. So if you can see, it's descending. And it's all because of the way we defined, it's up to us, it's all because of the way we define compare to. And here we're saying this will return, comparator will return a positive value when the radius of the current object is smaller than the radius of the input argument. Okay, so this is the creative part that we do. It's not the comparator or anything, it's the return. It's writing what's returned from the comparator. So I think that's kind of a lot right there, but are there any questions, or if you're, I understand also you might be confused because it's new and it can be difficult, but the one thing is, I'll say, at least as far as quizzes or exams, maybe we'll have an assignment where it's different, but the comparator method is just one line. It's just one statement. We're taking the difference of two integers. So I know I've given assignments where the comparator method, the code is a little bit more complicated. But as far as tests, any kind of quiz or exam, the comparator method will just be, the contents will just be one statement. So I thought we could do something kind of fun now, students. So yeah, you always gotta be worried when your teacher says, let's do something fun. So no, that means, okay, yeah, time to go. Okay, no, okay. I did put up that second worksheet. So yeah, we're gonna go back to Eclipse in a second. Let me just stop sharing. First of all, feel free, I don't see anything chatting, but yeah, just feel free to shout out at any time or just indicate something that you want to give some input. Okay, so if we look at, let's see if I can find it again. It's all this sharing going back and forth. Okay, so I'm going to share this interface worksheet too. There are a couple of problems on there, and I thought we could try them. And so here, let me just share. Let's just. Oh, that's not it. So let me just share. Let's see if I can find it. Okay, so of course I can't find it. Okay, I think it has to do with, let's see what, oh, I see what I did, students. It's because of it's my inexperience with using Zoom. Okay, now that should be a little, yeah, okay, here, let me just share this. You know, the browsers are tabs, so I'm looking for something and I don't have my tab open, I get confused. Okay, so share. Okay, so again, this is what I put up, I think, over the weekend. We're going to try this interface worksheet 2. And there's also, you see that person class. So let's look at the first problem here. So edit the person class so that it implements the comparable interface. And we just want to compare persons objects by the length of the last name. And in this case, the person object with the shorter last name is considered to be the greater person object. And maybe we'll even try, I didn't write a main method for this, but maybe we'll try that. Okay, so it's a strange way to, normally you might think of the actual content of the last name, like, someone whose last name starts with A is less than someone whose last name starts with B, because normally when you sort, you go in alphabetical order from A to Z in ascending order. Okay, but we're doing it by the length of the last name. And so if we actually sorted them, the last one printed out would be the person whose last name had the shortest length. Okay, students, so let's go to Eclipse and we know what we're gonna do. Okay, so now all we have to do is write a simple compare to method. Okay, so now I'm going to stop sharing this and go back to Eclipse. Okay, so let me just see if I can find so here is, I had it under here because I'm, again, very unorganized. Here's this person class you put as an example for your project. And so our goal now, we're going to implement comparable. So first of all, to implement comparable, we better write in implements and we're going to compare students, if we're going to compare person objects to circle objects, I would write this. But that's kind of silly. Again, we get a compiler error until you actually write the compare to method. But it's silly. We don't want to compare person objects to circle objects. But I'm saying theoretically, we could compare a person object to, a circle object or a string object. But it's always whatever after the class name. I've never seen it where what goes in the diamond operator isn't identical to the class name. Compare person objects to person objects. Okay, so now you see we got the famous red dot. And what is Eclipse trying to tell us? The type person must implement the inherited abstract method comparable compared to. It's kind of like, it's not necessarily the greatest message if you don't exactly know what they're talking about. Because what it's saying is when you, something that I never teach in Math 130 or 140, there's something called abstract methods where you're allowed just to have method headers, and that's what it's saying. We have this abstract method that's not actually implemented, or I guess we could declare a person as abstract. But okay, I'm kind of diverting from the main topic. I'm going to write I normally don't like writing methods at the top. I always like to write the instance variables and then constructor. Okay, but I'm going to write this method here just so we don't have to scroll down too much. So public, we have to we have to write a compare to method. So public int compare to, and now what's in the diamond operator? It's person. Whatever in the diamond operator, we put here. So, and then we just have to give the parameter a name. Let's just call it P. And we still have a compiler because now, well, it's not returning an integer yet. Okay, so students, but one thing I know when I have taught this in the past, a lot of students would make mistakes. And one, maybe they didn't prepare enough or they didn't notice the pattern. But notice that if the class name is person, what goes in the diamond operator after comparable is person, and the parameter to the compare to method is person. And now our goal here is we have to return an integer. And remember what we said in our rule, we make up the rule. What does it mean for a one person object to be bigger than another? So I kind of came up with this silly rule. The person with the shorter last name is going to be the greater person object. So we want to subtract off. Okay, so let's just try this here. So let's just say, let's say the current person's. It's just in case you're confused. So let's say the current person's last name is equal to, I don't know, red. It's kind of a silly last name. I'm just thinking of somebody with a short last name. And then the input person is equal to, I don't know, blue. Okay. Okay, so we see that blue has more characters than red. We want the person the current person's last name is red. That's going to be, okay, the bigger person object. So the way we're going to write this, since the current person's last name is red and the input person's last name is blue, the current person would be greater than the input person. Okay, so what if we went like this? So let's just say we went like this. So this dot last name, and then we need to get the number of characters in last name. So it's a string length minus p dot hello last name dot length. Okay, well the compiler error why isn't the compiler error going away? Why doesn't it like me? The left, sorry, student. Hello, return, okay. Okay, so we're returning an integer. We're taking the difference of the last names. Okay, so in this case, what would this result in? Well, the length of red is 3, because this is the current. The input is the input is the input parameter. Its last name has 4 characters, 4. Oh, we get -1. That's not what we want. Okay, so we're actually, so the person with the shorter last name, okay, so if we actually use this as our code, the compare to will return a negative value if the current object had a shorter last name than the input object. Okay, so let's just try to change this. Return p dot last name dot minus this dot last name. And now we have 4 minus 3, which is 1. It's positive. Okay, so in this case, okay, if we subtracted the length of the last name of if the current sorry to say, if the last name of the current object has a smaller length than the last name of the input argument, we actually return a positive value. That means that this is greater than, so this is greater than p. We're returning a positive value. Okay, so that would actually be the answer, but now let's just try. I didn't set up a main method, but why don't we do that, students? Because we'll just do like for a few of them. Okay, so any questions? I know this kind of be complex here, okay. So that's, oh, here I have test person. What did I put here? Oh, look at that, students. What is all this? Okay, so I wrote this. We have create person objects. And so we're actually going to, I'm going to take this out, take this null out. Oh, this is probably for something else. How about blue? Sorry for these silly names, students, but I'm just thinking of short. Okay, red. Okay, so then how about let's make this one really long. Okay, so yeah, Hannah has a really long last name. Let's take this default. Come on with it. So here we have 4 last names. So according to the our rules, the last name, the person whose last name with red would be actually the largest person object. It'd actually be the shortest one would be the one with all the Z's, and then Monday, blue, red. And then we're going to display the names, and then what we're going to do is we're going to do the sort. So I'm just going to, sorry, so this is, I'm not sure, I'm just going to comment all this out. So we're going to first initially print out, and then just print a blank line. Okay, so /n sorted list. And because person, and then we're going to sort it. We're going to use this built-in method. And what's the name of the array? Person, hello. And it's permanently changing the order of the array. And we have to actually import. Okay, now it should work. So first we should see the names in the order. Oh, there's also Smith in there. So it should print out Smith, Monday, blue, red, Z. We print out the original list, and then we print it out in sorted order. So it'd go from, we should see it in descending order, because the first one is the smallest person object. Oh, what does it? Okay, let's see what happens here. Oh, sorted list. I didn't. Oh, sorry, students. Well, it did print out the original list. Okay, so let's go back to. I have to do this. Yeah. So then, if you see here, let's see. Can I bring up? Where is it? What happened? What, students, am I sharing this with you? What happened here? I don't even see you anymore. I wonder if I lost you. Oh no, here I am. I wonder if oh no, I'm sharing. Okay, so are you seeing Eclipse? Just complain if you don't. Okay, so I don't know what that is. Okay. Okay, so yeah, so when we sort it, we see it's the longest last name and then Monday Smith. It goes in descending order. And so now let's just see. Let's go back to the person class. Let's try another way of sorting. So everyone here should be seeing the eclipse. That's what I'm sharing. So let me know if I'm not. And okay, so here let's just try sorting. Let's just do by age. The oldest person is the biggest object. Okay, so p dot age, oh, this dot age. So we're saying the oldest person is the oldest object. So it should sort in ascending order by age. The oldest person. Okay, and so why doesn't it, oh. So students, now let's try it again. We'll go to test person. Okay, so now we should see the original list and then, well, this actually is sorted already, so students, sorry. Here, let's just change some of these ages here. So let's make this person, let's say like 70, and this person is 6, I don't know, could be 59. Okay, so it should print it. So in sorted order, it should be 32, 45, 59, 70. Let's just make this 2. Okay. Okay, so first we'll see in the original order, and then it should be 2, 32, 45, 59, 70. Right, because that's because, so the sorted list is different because now it's all because of the way we wrote the compare to. It's because we changed the contents of the compare to. We're subtracting ages. We're subtracting the current age from we're treating the input age from this dot age. So yeah, I know that this might be a lot to take in, but notice one thing, it's really not a lot of coding. If you already have the class, we've done very little coding. All we've typed in is implements comparable, and we've typed in, then we've entered the code for the compare to method. So I thought we could try the second exercise, and then I'll talk a little bit about binary search. And the quiz will not have binary search, but. And then we'll do more on the chapter 2 in the Zybook next time. Okay, so, okay, students, so let's just do the second exercise then. And let me just stop sharing and then we'll go back to here. And so let's just see if I can, yeah, I'll just share this with you. Okay, so we're gonna write a class called rectangle, the famous rectangle class. And we might not do all of this, students, but yeah, it says this really isn't that hard. Okay, so so I'll only do part of this, and then maybe I'll let you do the second part. It says so we're going to have write this rectangle class with parameters, instance variables width and length, and we'll have a toString method, and then we're going to write a compare to method. We're going to sort by area. The larger the area, the larger the rectangle object. And then I had a part 2 to it, where I think it's like the smaller perimeter. Oh no, that doesn't help. Okay, I had a second part. I think it was like the smaller perimeter. I'd have to look at that again. But let's just write a rectangle class, and then we'll. Okay, so let's just stop. Yes, I'll stop sharing this. We'll go back to Eclipse, and we're going to write a rectangle class. Unless there's any questions. Okay. Whoops, I need to share. Okay, so I'm gonna, so why don't we, Okay, so I'm here, so I will just write it right here, just not that it's necessarily the best place. Okay, so let's just first create our rectangle class, and it's going to implement comparable, and I think it was height and width. Pretty sure it was height and width. So I'm pretty sure it was height. I'm just double checking, students. Just give me a. Yeah, height and width. Okay, so oh, width and length. I'm sorry, width and length. And then the constructor is width and length. Okay, so I think that I'm sharing this. Okay, so let's just create a class called rectangle, width and length. Okay, so first let's just do the private instance variables with. I'm going to cheat here. And then I'm going to go control. So at the constructor, I'm going to control. I did that like a right mouse click, and then I'm going to control. Let's see, let's go to source, and I'm going to generate. Where's generate constructor? Oh yeah, generate constructor using fields, and I'm just going to get rid of this super. All that super does, it just calls the constructor in the object class. Okay, so we've got the constructor, and I can even do the getters and the setters. Go to hit the right mouse button, go to source, generate getters and setters. Okay, so what we're doing is, okay, so then instead of wanting a toString method, okay, so public string, toString. Not going to use formatting. But we need this for when we sort. Okay. Okay, so we've got the methods, and so now what we said is we're going to implement comparable, and we're going to use a rule that the larger area is the larger rectangle object. Okay, so then implements comparable. Remember, you have the diamond operator. And so after the diamond operator, whatever the class name is, what goes inside the diamond operator, because all that means is we're comparing rectangle objects to whatever is in the diamond operator. It's almost always the same. Okay, so now what we have to do is, what happened to my constructor? Usually the constructor goes at the right below the instance variables. I don't. Okay, so then and because it says implements comparable. I haven't written the compare to method yet, so we have to put that in here. So let's just put it right here. And we're going to write public. And so compare to. So you get this part, if I say a class implements, like the class rectangle implements comparable, the integrated development environment could generate this code right here, right? Because it's going to be, this we kind of can do with our eyes closed. We know that if it implements comparable, it's got to have this method compare to, and the input parameter is rectangle. Okay, now it's what goes inside this method. This is the creative part. And we said, oh, the larger area is the larger rectangle object. So, so we're going to take the difference of two areas, and it should be positive if the area of the current, it's going to be positive if the area of the current object is greater than the area of the input argument. So basically, return positive. I'm going to use some kind of, not actual Java code here, but return positive if this dot area is greater than PR dot area. And if you subtract them, you're going to get a positive number. Okay, so just all we got to do is go return. There's no actual area method, or not that it's written yet. If you were going to write an area method, it should be private. Okay, so we're going to go return, and I'm just going to go like this dot width, multiply the input parameter, just multiply the instance fields, and then we can just go, oh, it's r dot width times r dot. And since notice I'm not using the get methods, I'm using a private instance variable. So why can I do that? You know, students sometimes don't like it when I do that. What's the name of the class? It's a rectangle. And so I'm working, so when you work with a and this input parameter r is also rectangle. So if there's a variable, so if we're working with a class and we're working with a variable with the same class type, we have direct access to its instance variables. If I used a rectangle object outside the rectangle class, I would not have direct access to the instance variables. But it's only because this parameter rectangle r is defined in a rectangle class that we have direct access to its instance variables. Okay, so notice that, let's look at this compared to method. It's positive if positive, right? So positive, can't spell positive, so it's positive when this dot area is greater than r dot area, right? And which means that this is greater than r. Remember, that's the rule. If compare to returns a positive value, then this is greater than the input argument. And that's not obvious. It's just some rule that's been passed down over the decades starting in the late 90s. Over the last, that's when Java started, like the late 90s. So someone made up this rule maybe 20 years ago. They're probably thinking, who knows what they're doing now? Okay, maybe it's on their resume. I came up with the rule for compare to. Anyway, okay, so now students, that's all we had to do. So let's remember the problem. We wanted to write a rectangle class with private instance variables width and length, a constructor. I didn't say the getters and setters, but we put them in anyway because I got Eclipse generated. We wanted it to have a two-string method, which we have, and then because the class had to implement comparable. And if it implements comparable, then it must have a compare to method. Without that compare to method, right? So without the compare to method, we get a red dot. If you implement comparable, you must have a compare to method. Okay, so students, why don't we just try this? We'll just come up with a few rectangle objects and print them out. And then, unless there's any questions from anybody. Okay, so. Let's just call this rectangle. I could have had it generate the main method for me. I keep forgetting. So public okay, so let's just create an array of let's just call it ARR. Let's just call it, okay, so here the area will be comma 1. So there the area is 1, and here the area is 8, and then how about maybe one with area 4. What do you say, area 4, so 2, 2. Okay, so let's, okay, so we create it, so why doesn't it like, what am I doing here that's wrong? Okay, rectangle ARR is, oh, right here, students. This is where I start getting nervous. Hey, where's my, everyone's watching me, where's my compiler? Okay, there it is. That wasn't too hard to find. Okay, so let's display the object. So for every rectangle R in ARR, and we're just going to print it out. And all we have to do is go, yeah, all we have to do is say the name of the object, and that's equivalent to, right? Then R just prints out R dot. If you just go R alone, it's R. It means it's just shorthand for R dot toString. And then we're going to sort it. We're going to put the name of the array in there. And we have to import. And let's just display, okay, so let's print out some message here. Original list, I don't know, something like that. And then sorted list. Yeah, and then we have to do the enhanced for loop again. All right, so now let's see how it happens. So the way we wrote the compare to method is that the middle one, the one whose width and length is 4, 2, right? Because the area is 1, 8, and then 4. So it should be the 1, 1 when we sort it 1, 1, 2, 2, and then 4, 2. Okay, so let's see here. Yeah, so it printed out the rectangle object in the original order, you know, and so the one whose width and length was 4, 2 is in the middle. And after we sort it, because, you know, first the area is 1, 4, and then 8. So I guess if we put one more, let's just do one more, and then I'm going to talk about maybe introduction to sorting, no, searching. How about 100, 3? It's definitely the biggest, right? Area 300. And that would go at the end. Because now after you sort it, it's using our rule. Again, how is it determining the sort? So when you sort, you have to be able to compare two objects of the same type. You know, which is bigger and which one is smaller. That's how you order things. Well, you know, you have to be able to use the greater than and less than operation. Again, it's sorting based on this rule right here. Line 13, that determines the sorted order. So if the current area is greater than the area of the input object, then the current object is bigger than the input object. Sounds like a lot to say, but okay. So students, your next quiz, I'm going to put I'm going to put the worksheets up there with my solutions. There's actually one more. I'm going to let you try that yourself. I'll put a solution up, but I'll let you try it yourself. Where I think it's the smaller perimeter is the bigger, considered the bigger object. So in that case, it would just be, you would subtract off the current perimeter from the perimeter of the input object. But the one thing about, on the quizzes on the test, if you're compare to methods, if the contents of the compare to is more than one line, then, you know, maybe you're making a mistake. I see some students using if statements, and I think they're making it longer than it has to be. Yeah, really, the comparatives are, I think, for the quizzes and tests are relatively uncomplicated. I'm going to just stop sharing here and just talk a little bit about what we're going to do in the future. Unless there's any, are there any questions from anybody? Okay. Yes, we've been here almost like 50 minutes. So we're going to start using the book a little bit. I'm not sure if I've never really used it. It just has some reading material in it and has some animations in it, and we'll see if it kind of helps or not. So let's see here. We're going to talk about something called binary search. why don't we use the notes a little bit, and then maybe I'll look at the zybook. There's no zybook assignment right now. I'll create a module and we'll start getting more into the zybook chapter 2 next time. But it also says students. Anytime you want to go, that's fine. You're not hurting my feelings because it's not a requirement to be here. And I am recording this. Okay, so let me just share this screen. I put up these really great, hopefully, I'm not sure how great I wrote them. We're going to talk about sorting and searching. So we're going to, I know before I always would do sort before search. But we're just going to do a very simple search algorithm. And it's called binary search. And you have to assume that your original array, so we're going to search in an array. And we're going to assume that the array is sorted. And so what you're going to do is the user would input a key. And say, oh, is this value stored in the array? And if it is, you return the index. And if it's not in the array, you return -1. And I will tell you, since I'm just taking the code, I'm using the same code as the book, and they do use multiple returns. I am not gonna, so I learned the hard way not to change any codes I find in a book. I've learned the hard way. It's probably better not for me to rewrite them. Okay. So let's just give an introduction to this. And hello, okay, so yeah, so am I sharing this? Yes, so this should be online. I think I haven't created a module yet, but there should be a folder under, I think, files, and it should say binary search. Is that right? Yeah, it's lecture 6. Is this lecture 6? Yeah, lecture 6, binary search. And if I see anything that needs to be changed, okay, so let's see, what did I do here? Okay, I think so you should see my PowerPoint slides. So I get a little mixed up when I'm using Zoom and I'm sharing. Okay, you probably all know that by now. Okay, so let's say we have this, and I think that's sorted, the sorted array. And let's say we want to return the index of 400. And if 400 is not in the sorted list, we'll return -1. But okay, we see that 400 is in there. Okay, it's actually close to the end. So one strategy is, well, let's just use linear search, and that's what we would do in Math 130. Let's just start at the very beginning, and just start at 0. So position 2 is not 400. Let's go to the next one. 7 is not 400, and you go on down the line. And eventually you get to 400, and what would you return? So it requires 11 compare. Are there 12 values in here? So 3, 6. Yeah, there's actually 12 values in there, and we stop. And 400 is at index 10, which means it's the 11th one in the list because we start counting from 0. So you actually would have to do 11 comparisons, which, to be honest, students, is like a grain of sand. Let's say you're at the beach, and so 11 comparisons is really nothing. But it's sometimes when you get these huge lists, so we're just doing ridiculously small problems, but sometimes you're doing searching on really longer lists and you're doing it over and over and over and over again. And then all these comparisons become expensive in terms of time. Okay, so we want to just keep in mind, the number of are we doing a necessary number of operations? Even though for our little practice problems, we'll never really even notice in terms of runtime. Okay. So, so if we just do a linear search, you start from 2 and go left to right. Yeah, you'll do 11 comparisons. And if it was not in the list, you do like 12 and then you go off the list. Okay. Okay, so there's the code I wrote. Start with index is -1, flag is false, and if I is less than, initialize I is 0, and if I is less than the array length and not flag is true, then you just check, then we just set flag is assigned. We compare array of I and whatever the array, I'm assuming the array is called array of I and 400. If that's true, it'll stop us the next time because not true will be false. And then you just set, and if so flag is true, when you exit the loop, you just set index to I-1. Okay, so hopefully this makes sense. the idea here, since I wonder if this is more wordy than necessary, I'll show you the, then we'll look at this, maybe we'll look at that animation in a minute. But the idea here is, let's just go look at the, do I have the list right here? Okay, so let's just look at the list, students. Okay, so there's the original list. The thing is that we know that it's sorted. So instead of starting from 0, let's start in the middle. Okay, and if that middle position is less than, so we're looking for 400. So the middle position is that we just take the index of the last minus the index of the first and divide it in 2, we get 5. Okay, so if we go to index 5, which is 15, we know that 15 is less than 400. But because it's sorted, we also know that everything to the left of 15 is less than 400. So there's really no need. So if you check them, so again, you have to have a sorted list. Okay, but 15 is less than 400, so that's got to mean that everything to the left of 15 is less than 400. So if we're searching for 400, and if the middle value is not equal to 400, so if the middle value is less than 400, all we have to do is search to the right of the middle. And if we were looking for, let's say we're looking for 7. Okay, we start in the middle, 7 is less than 15. Okay, that means that 7 would be less than everything to the right of 15. So then all we have to do is look to the left. So we're cutting in, each time we're cutting in half the number of possible candidates. It's pretty much, I don't know, maybe I might reword this because it's kind of wordy here. Okay, so what basically is to start in the middle of the array. Okay, so here's one case. So the middle of the array, we just subtract we take the average of the first index and the last index. So I'm not really saying how to get mid, but okay. So here's the case. So you go to the middle of the array and, oh, it turns out you found the element you're looking for, so you just stop. Okay, so now here, so here just would be the first step. Now let's say you're going to the middle of the array, the middle index of the array. So you just average 0 and array, the length of the array minus 1. Okay, now we're assuming that ARR of mid is greater than 400. That means that everything to the right of mid must be greater than 400. So you only have to look on the left. So now just search on the left side and go and then the next time look in the middle position of the left side. And then there's case 3. Okay, we go to the middle element. Okay, and that's less than 400. So it has to be on the right side because everything to the left of mid is also less than 400. So now you only have to look on the right side of on the right half of the array. Now let's go to the middle of the right half. So that's the idea, is you just keep chopping the array in half. So let's just look at, I'm not sure what else there's not really a lot of slides here. Okay, so we'll go back to that in a minute. Let me just share. Any questions on anything, students? It's really not too bad. Here, maybe we'll just do, so let's see here, students. Let's just do this one here. Let's just look at this one slide here. What elements do we look at? Okay, so we start in the middle. We're looking for 400. So we look in the middle. So there's 12 elements. So the last index is index 11, and we just take the average. So we're looking at that entire array. 11 plus 0 divided by 2 is 5. So we go to index 5, we go to the middle element. Oh, that's 15. That's less than 400. So now we just looked at everything. So now we just look in position 6 to 11. So now, okay, so 15 is less than 400. Now we're going to look halfway between 6 and 11. So now your second step, you take the average of 11 and 6, which gives you, is that right, 8? Yeah, because that's 17 divided by 2. So that turns out to be index 8. And now we go to index 8, which is 2, and that's 202. Now, oh, I'm sorry, since this should be 400. I'm gonna have to correct that. Okay. So array index element 8 is less than 400. So that means that everything to the left of 8 is less than 400. So now we look to the right of 8. Let's just look in positions 9 through 11. So we'll go halfway between 9 and 11. So we take the average of 9 and 11, and we get 10. and it turns out array element 10 is 400. And so we return 10. So each time you're sorting, so the first time we actually look at the whole array, and the second time we'd be looking at, okay, the second time we're just looking at the right side. The second time we're just looking at the right side, and we get, so we look in the middle element and we look at 15. Oh, well, that's less than 400. Let's just look on the, so now we look on the right side of 15 and go halfway. We go here in the middle there. Oh, we're at 200. Well, that's also less than 400. So now let's just look at, sorry, it's getting kind of small. Now we're just looking to the right of 200. So we get 300, 400, and we're going in, and we go in the middle. We go in the middle of the right side of 2 over 2, and we get 400. So each time we're just cutting the size of the array in half. And so, okay, so maybe let's try to see if this kind of helps. And then I just have a couple more things to say. And I'll let you read that section on your own here. So let's see if this exciting animation helps. So any questions? Since I think binary search is not too bad. So let's just stop, and I'm going to stop sharing here. And oh, the one thing I want to show you is, okay, so I want to share, if I can find, hopefully I have the zybook open, which I think that, no, that's not it. Here, let me just try this. Let's see if this is the, let me just share. Let's see here. And oh, that's strange. So let me just see here, students, and then let's just, yeah, I always care about what I'm going to show you my grade book. We're just going to look here, see if I can just. So it's just these simple exercises in here. So yeah, let me just, I think I did this. I wonder if I think if I start, it clears it. So let's see. Okay, so the white values have not been searched, and then the blue is the current, and then when it's searched, it turns gray. So here you have this short list, and you're searching for 16, and okay, so I'm not sure if this animation helps or not. Let's just try this. Okay, so so the current will be blue, and when we move on, the ones that have been inspected will turn gray. Okay. Okay, so let's see here. So it's going kind of slow. So it just takes the average of 7 and 0. And if, yeah, so it goes to, yeah, and it goes to position 3, and that's 14. So that's 14 is the current. Oh, and so it says 16 is now equal to 14. Okay, 16 is greater than 14, so we're going to go to the right side. Let me just press this again. And let's see what happens. So now it looks to the right of 14, and so that's position 7 minus 4. And okay, so, oh yeah, so somehow, okay, so yeah, so 7 minus 4 divided by, where did it do that? Did I miss that? Okay, so let's see what happens here. So let me just, okay, so I guess that's done. What I feel like I missed a step there. Okay, what happens when I do this? I guess that's probably not giving you a lot of confidence that I missed a step. Okay, let me just try this one more time. Okay, missed a step where they said how they got to the middle. Okay, so first they start at, you can just keep doing this over again. So the first time, yeah, it's 7 minus 0 gives you position 3. So you start it, we're looking for 16, and we go to 14, and we see that 16 is not equal to 14. So we should go to the right. This is the part that I think I missed. Let's see, does it have it here? So we're going to look to the right of 14. So that's positions 4 through 7. So it should take the average of 4 plus 7, which is 5. So it should look at 24 next. So let's see what happens here. 16 is greater than 14. So the mid is 4. And then, oh yeah, and so it kind of went a little fast there. I think it's just going too fast for me, students. Yeah, it did that kind of fast. It did the high -4 and got to that position 5 pretty fast. Okay. Okay, so we've looked at 14, the current is 24, and now that's greater than 16. Okay, so then, okay, so now we should just average 4 and 4. So the low is 15, yeah, and so then, and it should look to the left of position 5. I feel like this is kind of fast. Okay, so, yeah, I feel like that's a little fast, but you can tell me. Okay, I mean, you're probably, who is this teacher? He can't even follow this animation. So, yeah, I guess maybe you guys, you get older, you need slower animations. Okay, so students, let me just show you the code. And then, students, one thing I want to show you. So the one thing they do in the Zybook, they give you, it's pseudocode. Okay, and so numbers will be the list, like the assorted list. Numbers, sizes, you don't actually have to look at the whole array. It's just if you want to, it's kind of general, so you can just look at, so if you don't want to search for the entire array, you just say, okay, number size, it will tell you the last index that you want to sort in. So, but if you want to search for the whole array, number size is actually the length. Okay, and so then I actually, let's see what's down here, students. So let's just maybe do one of these exercises. Okay, okay, so let's see here. Is that the one I wanted to do? No, that's not the one I wanted to do. Okay, so so let's just try this simple one right here, students. Okay, so in this case, the list is just a list of strings. Okay, so a contact list is search for Bob. This is kind of easy. So you go in the middle. So there's 6 elements. So you want to go in the middle. Okay, so the index of the last value is 5, 0 through 5. So 5 plus 0 divided by 2 is 2. So the next, I believe, I'll just show you. Let's say you typed in the wrong answer. You type in Amy. I know it's maybe too simple. And it allows you, in case you make it, okay, so it gives you a clue. And you can do this as many times as you want. Okay, so, so we typed in the wrong answer. Okay, so it should be position 2, 5 plus 0 over 2. So, okay, so I got it wrong. Okay, okay, 3. Oh, it's 7. So, okay, okay, students. So, and I did that deliberately. It's 7. Okay, it's position 3. I'm sorry, students. Yeah, so Zoe is at position 6. So it's 6 plus 0 divided by 2. So we're actually going to go to position 3. So it's actually Holly is in the middle. I guess if I eventually type all the names in, I'll get it right. Okay. Yeah, so Holly is in the middle. Okay, but we're looking for Bob, and if we're sorting alphabetical order, Bob is less than Holly. So now we look directly to the left of Holly, and so now the remaining elements so Holly is greater than Bob. So that means that everything to the right of Holly has got to be greater than Bob. There's no way that Bob could be to the right of Holly. It's got to be the left of Holly because it's sorted. So now we just look on the left side, and it's position. So Holly's at position 3. So we look in position 0, 1, and 2. So we take the average of the first minus the index. We take the index of the first and the last. So it's 2 plus 0 over 2. Okay, divided by 2, that should be 1. So the next one should be, hopefully I did this one right. Yes. So it's pretty easy, students, some of these participation exercises, and hopefully you'll learn something from it. If you get it wrong, you get to do it again. And then the next time you open the Zybook, if you want to study, the answers will be gone. There'll be a check mark that shows that you've actually done it, but that you've already tried it. but the answer will be gone. So let me just show you the code, and then we'll stop in case there's any questions. And this is not in your quiz, students. So I'll put this part of the next module, but I think it's kind of simple enough. And I did do the code, so let me just stop sharing this. And I actually made the code. I went beyond expectations, students. Let's see if I can. So far beyond expectation. I'm kind of, hopefully I can find it. Okay, so let's see, it was zyBooks. I put under zyBooks. I put these, a lot of times I can't remember where I put my files. And so in the, oh, I have to share this. So can't see that, can you? Yeah. This will be the last thing I'll share. Okay, so so here's the binary search, and I converted it from pseudocode to real Java code. So maybe that'd be good exercises for some of the remaining assignments. And then I have some print lines in here just so for my own debugging purposes. So I'm going to take these out right now. Well, maybe we'll put those back in so we can see that. But okay, so here's where, and here, so students, I do have more than one return because I'm not gonna, I don't want to mess with the code in the book. So, and I learned the hard way. It just gets way too confusing. I used to use a harder book than this, but that's when I taught in class. But okay, so again, so we're always going to search at position mid. We're always going to compare. So we put in the array. That number size, for the most part, is always going to be equal to the length of the array, but we're not required to, maybe the array is length 20, and we're only going to look through positions 0 through 10. In that case, we'd say number size is 11. Okay, so we can actually just search through part of the array if we want, and then we put a key. That's what we're searching for. Okay, so low starts at 0 because that's the leftmost element. High starts at number size -1. That's going to be the index of the rightmost element. Okay, and so while high is greater than or equal to low, so while the index of the rightmost index is greater than or equal to the leftmost index, we take the average, and then we're going to check to see if that middle element is greater than the key, less than the key, greater than the key, or if it's, and if else, that means, and if the first, if the Boolean expression lines 12 and 14 are false, that means you found it. Okay, if eventually high becomes greater than low, that means you've looked at all there's no more array elements left to look at, and you return -1. Okay, so let's just, and then students, maybe we'll talk about this at another time. I implemented it twice. Now this is not, they don't talk about this in the book, but let's say we want, though that example that we just looked at, the one with the strings, you couldn't use that example. Well, they weren't strings, there weren't double quotes around it, but you couldn't use their algorithm. Their code is, well, actually it's pseudocode, so I guess you could. Okay, but if you want to do this binary search with objects, you have to, instead of having instead of searching for array of integers, we have to, the parameter would be an array of type comparable because we have to be able to compare, right? So you couldn't actually use this algorithm on an array of objects whose underlying class did not implement comparable. But we'll talk about that another time. So students, I have this, let's just do this one simple example, and then we'll pick up here next time. And so I have this kind of long array, and it's not equally spaced here. Maybe I wonder if I could format this. Yeah, that kind of picks up. So line 48. This is yeah, so I can't remember sorry, Susan, if I didn't upload this, I can't remember. But you look on line, and I will, but if you look on line 48, okay, there's an assorted list of integers. And so and I wrote it such a way, and then I print out all the elements, and then we're going to ask for a search key, and we're going to return the index. And so students, why don't we actually print out the mids? I think that's what I kind of, for some reason, So we'll just print out all the middles, like where it's going. Okay, and so let's just run this program, and I'll make sure it's uploaded if I haven't. Oh, it's giving me complaining because I actually haven't closed the scanner, which I'm famous for. Most people forget to do this. Okay, so let's just run this. Then we have our sorted list. So we will search for 900. We'll do this a couple times maybe. We'll search for 900. So enter search key 900. So we printed out the list, 951. Yeah, so it starts at position 8. So that would be, so 11 is position 3. 8, so it actually starts at 202. And so that's 202 is not 951. So now, so 951 is greater than 202. So now we look at all the values left of greater than 202. So it looks at the array elements from 300 to 1,000, and it goes halfway. So this would be, oh, now I forgot how many elements are in this. Sorry, since it's 3, so it's 3, 6, 9, 12, 15. I think that last element is at position 17. Yes, 17 minus 0 is 8. Okay, so we went to position 8, and it wasn't there. So 951 is greater than what's at position 8. So now it's going to be the average of 17 plus 9. So that's 26. We divide that by 2. Okay, so now let's go halfway between 300 and 1,000. We go to position 13. So 9, 10, 11, 12. Oh, there. 10. Okay, so let's see, 8, 9, 10, 11, 12. So I think it goes to, okay, so I've lost my count. Okay, so 8. Okay, so 3, 6, should have actually printed this out. Okay, so yeah, 202. Okay, so sorry about this. 3, 6. So 202 is at position 8. Okay, position 8 holds 202. So the next time we're going to go to position 13. So why doesn't that give? Oh, because it's 9. I'm looking for 951, not 901. So the next time you go to position 13, and that's 901. Well, 951 is greater than 901. So now we have to look on the right side of 901. We go halfway. So now it's, so we look at positions 14 through 17. We go halfway. So 17 plus 14 is 31 divided by 2. We go to position 15. And so, and that's what we found. So we did 3 comparisons versus, if we were doing linear search starting at 2, going 2, 7, 9, we'd do 15 comparisons. So binary search, greatly reduces the number of comparisons. So the greatest number of comparisons is actually log of n. It's about log of n comparisons versus n. Next time we're going to start talking about order of growth for algorithms. But if you're starting from position 0 and going all the way to the end, yeah, you can do as many as n comparisons. So if there's 1 million elements in your array, you could do as many as 1 million comparisons. Where what is 1,000? So 1,000 is about 2 to the 20. I mean, 1 million is about 2 to the 20. Whereas if binary search on 1 million elements, we'll do a most at about 20 comparisons. Okay, we can talk more about that next time. But hopefully I'm not confusing everybody, but let's just do this one more time. Okay, let's just do one that's not in there. So let's just try -1. That's definitely not in our list. Okay, so again, we start halfway, so halfway is always 8. Okay, so okay, so 8. So what's at 8? It's actually that, 202 is at position 8. So -1 is less than 202. So so the next time you look in positions 0 through 7, you had 7 plus 0, divide by 2, you go to position 3. Okay, -11 is greater than -1. 11 is at position 3. So now we look everything to the left of 11, 2, 7, and 9. So that's, we just take the average of, that's position 0, 1, and 2. We take the average of 0 and 2. We divide by 2, we get to position 1. Okay, well, 7 is greater than -1. Okay, so the only thing, so there is one thing to the left of 7, that's 2. So the first and the last element are both 0. And we divide by 2, we get position 0, but 2 is greater than 0. And if you subtract 1 from, and so now we look to the left of 0. Well, now you're at index -1 and we stop. Okay, so, but in each case, it just keeps going halfway. So I'll put that code online, but so this is not on your next quiz, but I'll suggest as a reading. I know it's kind of fast. No one's really asking questions. Hopefully, I know sometimes when I was a student, I would get lost. I'll be honest, I would get, probably because I wasn't paying attention. I don't know. I took a lot of math classes and I don't know. I think about 5 minutes in, I stopped paying attention. But I regret it, students. Don't do what I did. Okay, I deeply regret not listening close to my teachers. Okay, so are there any questions right now? So your quiz, and I will put the review questions up there. Like I'll do all these, I'll put solutions to these. And all you're gonna have to do is just implement comparable a couple of times. It shouldn't be a bad quiz. And I might ask you to write a whole class and implement comparable like I did in the assignment. So I might give you a class and then ask you just to implement comparable, and then maybe and then give you another class. And I might even give you the test class so you can test your code. So hopefully, you'll learn a lot from it versus just kind of scrolling out the code. And like in regular class, you just write the code and you're not really sure if it's right because maybe you don't have a test file. So yeah, so your next quiz, which I'll post by Wednesday, will be just on the comparable interface, which means all you have to know how to do, students, is write a compare to method. So any questions right now? I will stay here until everyone's gone. But if you don't have any more questions, you should feel just kind of like the class is over, and I'll just be here to close the door. But I'm available for questions, either email or Zoom. And I'll post this recording. Am I the only one here? So I'm going to stop recording.